This is video 2.12. This is our last video in Unit 2. We're going to talk about a topic that will come back up throughout the year, the ground state versus excited state. So here on the left, we have neon in its typical arrangement. Okay, 2 electrons in the inner shell and 8 on the outer shell. So what will happen is that energy in the form of a photon beam will come in and will excite electrons. They will then jump up to a higher energy level and when they get excited, all right, and now they're no longer in their lowest energy state. Okay, so that's what's called the excited state. So ground state are electrons in the lowest energy configuration. All right, that's possible. This is the configuration that is found on your periodic table. All right, so you'll just kind of check that. And this is where they want to be, right? Because they're lazy, they don't want to exert extra energy, so they're going to stay in that lowest energy possible. So for example, lithium has 3 electrons. It would be in its ground state 2-1. Okay. Now the excited state is when electrons are found, like I was just saying, in higher energy levels. So they've been excited. Kind of like a kid when you give them candy, right? They get hyper, so they get really excited. But that doesn't really stay all too long. Eventually they will crash back down and they come back down to the ground state. And we'll talk more about that in a few minutes. This is any configuration that is not found on the periodic table. Okay, so make sure you have your reference tables out, specifically your periodic table, because that's going to be your biggest tool to help you remember it. So lithium, right, we know it has 3 electrons, so it could be 1-2. Notice how there's still a total of 3 electrons there, or 1-1-1, still 3 electrons, so we know it's lithium, but they're just in a different arrangement. They've been excited, okay? Just remember that the excited state is very short-lived. It doesn't stay for a long time. So these are typical questions that you could be asked on your Regents exam. So is it the ground state or is it the excited state? So 2-1, if you see it on the periodic table, you know exactly as it's written. You know that it's the ground state. If it's the same number of electrons as an element, but it's not written how it shows it on the periodic table, you know it's the excited state. So what you want to do is just add up the numbers that you have in the configuration to find what element that is, instead of just randomly searching, trying to find the right one. Add the electrons up first, it'll make it go faster, and then if it doesn't match up, the configuration given to you doesn't match up to what's on your periodic table, then you know it's the excited state. So 2-1, so that's lithium. When you look at lithium, it is 2-1, so you know it's the ground. 2 plus 0 plus 1 is still a total of 3 electrons, but it's not what's on the periodic table, so you know it's the excited state. So if we look here, right, 1-1-1, that's still a total of 3 electrons, but when you look on the periodic table, it is not what's written there, so we know it's the excited state. Okay? And I don't know why that just happened, but hopefully it won't do that anymore. So take a look at the next one, right? 2-7-3. All right, so add that up. 2 plus 7 is 9, plus 3 is 12 total electrons. So when you look that up, that's magnesium. Does this configuration that's given to you match what's on your periodic table for magnesium? The answer is no, so you know it's going to be excited. All right, let's look at the next one. 2 plus 8 is 10, plus 2 is 12. So again, this is magnesium. Now it matches up, so I know it's the ground state. So I would encourage you guys to pause the video, go through and try these last 5, and come back and check your answers. So the next one, 2882, all right, that would be the ground state. So that would be number 20, which is calcium. 28176, when you add that up, that's 10, 27, 33. 33 would be arsenic, all right, but that is not what you find on your periodic table, so that's excited. 10 plus 18 is 28, plus another 8 is 36. That would be krypton, and that does match up with the configuration that's there, so that's the ground state. And then these last two, when you add them up, guys, you should find that they are both the excited state for their respective elements. All right, so that's basic configuration that we're looking at right there. That is what you're going to need to know on the Regents exam, but this is an application of that. Now, the one thing you want to remember is that the greater the distance from the nucleus, so greater distance from nucleus, the greater the energy. And that should make sense, right? The further out you get from that, it takes more energy to get around. So it's like a longer lane in a track. Like if you think about the distance traveled by the outside lane on the track, like in gym class, or at a track meet, they start up closer because there's a greater distance, so it takes more energy to go around that same distance. So the greater the distance you are, the further away, the more energy they have. Okay, so the piece that we were just talking about is when ground state electrons absorb energy, they will jump to a higher energy level. Okay? They get excited, they get hyper, or what we call the excited state. All right? This is very unstable, like I was alluding to a few minutes ago. Unstable / temporary. Okay, so think about it again. You give a kid candy, right? Oops, I did not spell that right. Temporary. When you give a kid candy and they get hyper, they don't stay there all too long, right? Eventually, they're going to crash back down. Same idea here with these electrons. They don't want to be in that higher energy state, so then they will emit their energy, they will release it, and they'll fall back down. So excited electrons, I don't know why that just jumped. I apologize. It did it again. Oh boy. Let's get through this. So will rapidly fall back down or drop, these are terms that you could see, to a lower energy level. Okay? So they will drop down to a lower energy level. And what they do, though, when they do this, is that those excited electrons, they release energy in the form of light. Okay, so we will actually see the light. These are things like fireworks. Okay, this is how they work. We're going to do the lab on flame tests, and we're going to talk more about it in detail. That's how we see it, or neon signs, right? Same idea is used there. So just to kind of reiterate, when we go ground to excited, energy is absorbed. Okay. This is what's called a dark line spectra. Is produced. So excited. I apologize, guys. I do not know what's going on. This is driving me crazy. This is the third time I've tried to make this video and it still keeps going. I'm just rolling with it now. So excited to ground is where we have the dark line spectra. So that's this one right here. Okay, that's your dark line spectra. I'm going to change up colors just to kind of coordinate here. When energy is released, okay, we get what's called bright line spectra. It's going to do it again. Okay, and this is that bright line spectra. Guys, each element has a unique bright line spectra. You might remember this from earth science if you've done this. So just to kind of summarize this, dark lines are when they get absorbed. Oh my goodness. Bear with me before I throw my tablet. Dark lines are absorbed. Okay. Bright lines are emitted. Okay, when we're emitting energy. Now, this term is called the Balmer Series. All right. This is where electrons falling from the excited state down to the second energy level, give off visible light. And really, this is just this, oh boy. Okay. Bright line spectrum, we're just going to fill it in and we'll talk more about this in class. Or visible light spectrum. Different elements produce different colors of light or spectra. The spectra are unique, so each element has a unique spectra, guys. This is how like the Mars rover identifies what elements are on Mars, is shooting this, light or energy at these particles, trying to excite them, and then seeing what emission spectra is released. Okay, so until next time, I'll see you guys later.